Hello friends, I welcome you in lecture number 30 on logic. In this lecture we will discuss two examples on quantifiers and we will see how we can transfer or write given statement in symbolic form. We have discussed about universal quantifier and existential quantifier in previous two lectures. So if you have not seen those two lectures, I suggest you to watch those two lectures first and then go for this lecture so that you can understand how we can write given statements in symbolic form using quantifiers. So in this example we have taken these statement functions. Suppose mx denote the statement function that is x is main. Similarly hx denote that x is a mortal, ax is for x is an apple, Rx is for x is red, Nx is x is an integer, and Px denote the statement x is either positive or negative. And using these statement functions we have to write the following statements in symbolic form. So first statement is for all x, x is a main, and we know that whenever we want to quantify that some statement function is true for all x, then we will use universal quantifier. So for all x we are writing this symbol for all x, and x is a main that we have denoted by mx. So we can simply write for all x mx. Some authors are using brackets also. Instead of writing in this way, they are writing for all x in the bracket and mx in the bracket. Both are valid notations. So for all x, x is a main can be written in symbolic form in this way using universal quantifier. Instead of writing this for all x, x is a main, we can write in this way also, that everything is a main. Everything is a main. So either they ask to write this or this. These two are equivalent statements and we will write them in this way. Second is for all x, if x is a main, then x is a mortal. So here also we have to use universal quantifier. For all x can be represented by this universal quantifier. Here we have two statements. If x is a main, that we have denoted by mx, then x is mortal. So for x is mortal, we have used this notation h of x. For all x, if x is a main, then x is a mortal. So we can see this is conditional statement. If and then are used here. That is, if x is a main, then x is a mortal. That means if mx is true, then hx is true. That is, mx implies hx, and that is for every x. So this we can write in symbolic form in this way. For all x, for this we write for all x. If x is a main, then x is a mortal. That is, mx implies hx. So here we are using this implication. We are using this logical connective which we consider as implication. So mx implies hx. This is in the bracket. Instead of writing this in this way, that for all x, if x is a main, then x is a mortal, this statement we can write in another way as all men are mortal. So if they ask you to write down this statement in symbolic form, then also we have this representation using universal quantifier. So whenever we have if and then like situation, we will use conditional statement or we will use this one-sided implication, and this is for all x, therefore we are using this universal quantifier. Third one is similar to this. Here we have for all x and conditional statement. If x is an apple, then x is red. For x is an apple, our notation is ax, and for x is red, our notation is rx. That is given here. We have denoted x is an apple by ax, and x is red is denoted by rx, and this is for all x. And in other words, we can write in this way also, every apple is red. So to write down this in symbolic form, first for this we will write for all x. Then here we have implication. So x is an apple implies x is red. So that we write in the bracket that ax, that is x is an apple, implies x is red, that is denoted by rx. So in this way we can easily write given statement using quantifiers. We have taken this statement also for all x. If x is an integer, then x is either positive or negative, which we can write equivalently as any integer is either positive or negative. These two are equivalent statements. So if they ask you to write down this or this in symbolic form, we will have same expression. Now if x is an integer is denoted by nx, and x is either positive or negative, that is denoted by px in given problem. You can see here x is an integer is denoted by nx, x is either positive or negative is denoted by px. So here we first write for this, it is for all x. Then here also we have conditional statement. If x is an integer, that is if nx, then x is either positive or negative, that is denoted by p of x. So nx implies p of x is the representation of this statement in symbolic form using quantifier. I have taken another example. First consider these statement functions. Mx denote that x is a man, Cx is notation for x is clever, R1x denote that x is a real number, and for x is rational number, notation is R2x. And using this we have to write the given statements in symbolic form. First statement is there exists a man, that is there is some man here, there exists a man, that is there is at least one man. So this we can rewrite in this way also, there exists at least one man, at least one man. Or we can write in this way also, there is an x such that x is a man. All these are equivalent statements. Now for x is a man, our notation is mx, and for there exist we use existential quantifier. That we know that existential quantifier is used in this type of situation, the situation in which statement function is true for at least one value of x. So here there is an x that I can write in this way, such that x is a man, is denoted by m of x. Or we can use brackets also. Some authors are using bracket, so we write this in the bracket and this in the bracket. So whenever some statement function is true for some value of x or for at least one value of x, or whenever we have this type of words in our statement, then we will use existential quantifier. So this there exists a man can be denoted by this notation, and this is the symbolic form for this expression. Second statement is some men are clever. So this we can understand in this way also, that there are some men who are clever, or if we write in the form of object, then we can write in this way that there is an x such that here we have two characteristics, x is a man and x is clever, such that x is a man and x is clever. I have written this same statement in another equivalent form, or I can write in this way also, there is at least one man who is clever. So now if I want to write this in symbolic form, then for this I will write there exists x. Now here I have two statements, x is a man and x is a clever. X is a man is denoted by mx, x is clever is denoted by cx. So for this we have mx and x is clever. For this our notation is cx, and here both the statements are true, that is x is a man as well as x is clever. So we have to use logical connective, which we know as AND operator or conjunction. So I have to write conjunction of these two statement functions mx and cx. So there exists x such that mx and cx. So this is the symbolic form of this some men are clever, that is there is at least one man or there is at least one x which is such that x is a man and x is clever. So we can use these quantifiers as well as logical operators and or conditional implications, and we can easily write given statement in symbolic form. Next one is some real numbers are rational. So this also we can write equivalently in this way, that we can write that there is an x such that x is real number as well as rational number. X is real and x is rational. Some real numbers are rational means there are some real numbers which are rational also. For example, we know that 3/4 is a real number and it is rational number also, and we know that root 2 is a real number but it is not rational number, it is irrational number. So that is meaning of this statement, that we can have at least one x such that it is real as well as rational. So for this we have to see what are the notations for x is real and rational. X is a real number is denoted by r1x and x is rational is denoted by r2x. So this is our r1x, x is real, this is denoted by r2x, and here we require there is at least one x, therefore we use existential quantifier, there exists x, and here both the statements are true, so we use AND operator r1x and r2x, and we obtain the symbolic form of given statement. So in this way we can write down given statement in symbolic form using either universal quantifier or existential quantifier, and these logical operators which we have discussed in earlier lectures on propositional calculus. So this is all about this session. We will continue with this lecture series of logic in future. Thanks for watching.